Cool. So first of all, my apologies. I don't think we were live on Twitter for the last 1 minute or so.
Yeah,
But there's always something happening. So yeah, just for the Twitter followers. Hi everyone. My name is Radu. I'm a senior dev partner manager at Dfinity, and yeah, we're having the first DAI live stream, which kicked off with some technical difficulties. Uh, so yeah, together with me, I have Wyatt from Kinic and Ulan, my colleague from Dfinity. I very much apologize, Wyatt, but could you please reintroduce Kinic DAO so that our followers on Twitter see it again? And apologies for the viewers on YouTube that but actually they get to hear you talk one more time about Kinic, and you're one of the most enthusiastic speakers about this, so I don't think that's a big problem.
Yeah, definitely. I'm just going to do it a little bit briefer than I did last time. ICME actually started as a no-code, low-code Web3 suite for people who didn't know how to do coding, basically. I'm the technical founder. We had a bunch of people who were famous bloggers come and post their blogs onto IC and other Web3 projects, and they found out their SEO was worse than what it was. So Kinic actually started as a search engine on-chain to help these people get discovered. What we found quickly was these Web2 algorithms weren't as performant as LLMs and AI, so we really started to focus purely on the AI front. Because we think search is actually very much relevant to AI, and AI is the future of search. So Kinic is very focused on on-chain AI tooling, and we're making it as easy as possible. So if you actually go to ai.kinic.io, you can try some of the stuff out right now. There's a vector database, which is like a backend for AI, and you actually run some search models if you want to do that as well. Thanks.
Thanks. So maybe tell us more a bit about this vector database. What is it, and what is its role in the decentralized AI space?
Yeah, LLMs actually run in a bunch of different locations. You can run them on like Web2 servers, which is what most of us interact with if we interact with like ChatGPT or something like that. Or you can run it locally on your browser, or you can run it on blockchains in some circumstances as well. But really, like, where is the data coming from when you want to give the model adaptations? And this is what's called a vector database, and this kind of feeds AI models for doing certain things. So really, there's a process where you train a model, and then after you're done with that, you get weights in the model, but you guys modify it after that through a process called RAG, and that's where you use the vector database. So for example, like internal company docs or something like that, where you want to update it a little bit so it's more specific to your use case. That's where you'd use a vector database to feed the LLM specific data. To date, there's actually not been a Rust like open source version. So we released the first one called Vectoon. It's based on something called Vamama indexing, which is important because it allows you to update, like insert and delete, which is different from other vector databases that exist today as well. And completely open source Rust, so therefore it also runs the IC, which is awesome for our use cases.
I see. So you mentioned a lot about. I mean, you mentioned about local LLMs. So what are some potential applications? So first of all, what is a local LLM, and what are some potential applications that you see from your experience?
Yeah, it's not just LLMs. I think all AI is going to get miniaturized for a bunch of different things. One really easy one that we even have today is like biometrics. You scan your iris to open your phone, to have an example. If you can do that and actually prove the fact with something like zero knowledge proof, you can actually never expose your biometric data to anyone. So that type of use case where you run something locally, one for privacy, is a good example. And biometrics is also one of the like hallmark examples of that. But there's actually models that exist today that run pretty performantly like in your browser. One is called Candle, which is also a Rust library. You actually just run it, like you can compile it and run it in your browser. It's pretty performant for just general LLM type tasks. There's also other things that you run locally as well. There's one from Google that's an LLM type product. But I expect in the future that these AI products will get more and more miniaturized. You can just run them locally. And even then, like when that happens, how do you trust your data source that's feeding the AI? And that's what the vector database could be used for there. There's really two different branches, like B2B and B2C. The B2C one's like, hey, you want to train your own AI. It runs locally. It does something very specific for you. And you want to trust your data source. The B2B is a much bigger category where you're basically doing services. But we can dive into those or whatever you would want. But I would say B2B is where we're focusing right now. Like if you're a Web3 project that wants to do like internal search of your site or something like that, your open chat and you want to search through your open chat docs using AI. It's very much focused on that currently. But yeah.
So maybe now we can hand it over a bit to Ulan. So Ulan, we've just released the roadmap, and I think that most of our followers have seen it. First of all, like what's happening on ICP? Kind of what's the new? What are the new things that are coming up?
Hey Radu, thanks for organizing this and inviting. Maybe I introduce myself, like just so people know who I am. I'm Ulan. I'm an engineer at Dfinity. My background is in virtual machines, so I've been working with virtual machines for like more than 10 years. And at Dfinity, I also work on the virtual machine, and that's a virtual machine of internet computer is WebAssembly, right? So that's like the team I work in. And to answer your question, Radu, I think at least for me, the most exciting part is this decentralized AI part of the roadmap. I guess we can talk about other parts as well, but maybe it would make sense to start with this one, since it's also the topic of this space. Right. So should I just go ahead and explain the items in the roadmap? Or?
Yes, let's take it from there, and afterwards, I'm sure that we'll have some discussions also with Wyatt about the roadmap.
Right. Yeah, and also Wyatt, if you have like questions while I'm talking, feel free to ask. I was also not sure if I could ask you before.
Or yeah, sure.
The conversation is going to be fun.
Right. So I mentioned that I worked on WebAssembly. And WebAssembly is very important for AI. And maybe to give some background for people who don't know what is WebAssembly. So like, I'll not sure like what's the level of the audience, so I will try to assume like people don't know WebAssembly. So WebAssembly is a virtual machine, and what is virtual machine? Maybe you know that every blockchain has some environment in which smart contract code executes, right? And usually this is the virtual machine that executes the smart contract code. And WebAssembly is one of the, like at least for me, the most exciting virtual machines. I actually worked in the team that was designing WebAssembly before my time at Dfinity. And I think at the time when internet computer was being kind of designed or developed, they made a bet that let's use WebAssembly as a virtual machine. And I think right now this bet is paying off because WebAssembly is a great virtual machine. It provides security. It also aims for near native performance, right? So there's like not a lot of overhead, and that is what is important, and that's how it's related to AI, because AI, in order to run it on chain, it's very resource kind of hungry, or it requires a lot of compute and memory, right?
I think it's also interesting, maybe if we mention the history why WASM was created, was that there was a bunch of browsers with these different interfaces that had JavaScript, and they wanted to run near native code across a bunch of these different companies. And they got together and like, hey, let's make a format called WASM that we can all use to get this near native performance. And that's kind of just an additional fact of where it all came from. But now it's using like Web3, like Ulan was mentioning. But it's super portable, works in your browser. It's pretty great. We love it too. We actually have a ZK WASM implementation that we're open sourcing in a few months. So awesome.
Yeah. Thank you. Yeah. Right. So it was originally created like to run in browsers. That's why it's like the name WebAssembly. But now it's also like people realized it's actually general purpose, and you can like use it outside of browsers, and that's one of the applications as to run as like on the internet computer, right? So yeah, like as I mentioned, AI is very like resource, like needs a lot of like compute and memory, and we started to look into this like in my team like a couple of months ago. Like maybe you remember like when Dom made a demo of like image classification running on chain, and we used that to see what are the bottlenecks, right? And that's what the first milestone is about. Like that's the code name Cyclotron. And if you maybe expand that milestone, like this is going to be all about like performance, or like what are the bottlenecks, low-hanging fruits we can pick in order to make WebAssembly execution that's relevant for AI computation fast. And we are mainly, as I said, using this image classification, which is like inference. So like we're kind of focusing on the inference side of AI. And it contains 3 features. First one is already kind of done in the sense that it's an optimization we did in the WebAssembly engine that we use. That's called WasmTime. We already implemented that optimization in WasmTime itself. And now in order to get that optimization on internet computer, we are waiting until that version becomes stable. Then we can use it and like upgrade to it and deploy it on the mainnet. And there was I think public global R&D where a colleague of mine, Adam, presented technical details about this work. So this, like it gave quite impressive results. Like I think it did like 10x on like pure floating point operations. And in the context of that image classification example, I think it was about 3x improvement. Right. So that's so this is coming to the mainnet soon. Another thing that's also very exciting in WebAssembly, it's called WebAssembly SIMD. That stands for Single Instruction Multiple Data. And the idea here is that with single instruction, you can perform like up to 4 floating point operations. Right. So that's on the replica side, like on the internet computer side, we are almost done with it. So this part, I think maybe in a week or 2, it will be on the mainnet. Like it's basically we enabled it on master. I'm not sure about the schedule when it gets to mainnet, but and then soon it will be also available in DFX so that developers can test it out and try out locally. I'm also like looking forward to it. Maybe if you see any improvements there, like from in your examples, like the tricky part here is that it's not enough just to have the like SIMD enabled on like WebAssembly itself. Also, your program needs to use these instructions, right, in order to get the full like benefit from it.
Yeah, I think actually our vector database starts off with SIMD, and we're actually removing that, so it works on the IC right now, but we can obviously like add them back in.
Okay.
Yeah, that's more like general audience that's out there. There's like teaching AI takes a lot of GPU. And that's what they call training. Inference is actually the much lighter weight process. It just takes basically 1 GPU. You can do it on less constrained devices. So that's what we're talking about. Inference is basically like if you're a ChatGPT or one of these AIs and you type in a question, the output is the inference. And that's kind of where we're targeting right now. We've tried actually locally, we tried on the IC, we tried on a few different other places as well. Obviously like a high performance GPU backed server is the fastest. Like you type something and you get a bunch of tokens, a bunch of words back out. But with these improvements that Ulan's mentioning, we'll actually be able to run with more memory in the IC directly, which would allow for more tokens and more speed from this inference. So specifically, yeah, it would be very awesome to have SIMD.
So that's super cool. So I think that the end goal that we're having and kind of what Ulan is explaining is to have the entire process end to end, completely decentralized and completely on chain. Now this is like as both my panelists here explained, this is quite resource heavy. So we kind of need to stage it. So before going into the next milestone, I'll leave this on screen so that our audience can have a look. But maybe there was a point that Wyatt that you mentioned, and maybe that can lead us into our next milestone, which was kind of like verifiable data sources. And in my opinion, this kind of is linked with the training of LLMs, because inference and after this milestone is done, then inference can happen on chain, but training still is something that is resource heavy. So maybe can you talk us a bit about kind of what is the importance of verifiable data sources, and kind of what Kinic also has in mind, or kind of what how do you see the future in this regard?
Yeah, people spend millions and millions of dollars actually training AI. That's a very very resource intensive process. What people like us and other startups like to do is actually use the weights and LLM that already exist as models, and then tweak them. It's called fine tuning or reg for augmenting the outputs of these. So say you had an LLM that's just generally trained on text data, and you want to train it specifically for like Dfinity dev docs or some other developer document. You can actually give it that data and fine tune it a little bit just for that specific use case, and it's much less computationally intensive. It's a much easier process to do. So our vector database is really targeted at that type of use case. And the cool reason why it's cool that's tamper-proof is that you potentially have private data with vet keys. So like you can imagine a doctor putting a patient's data in to an LLM and not exposing that and knowing that the data they put in is not being tampered with whatsoever. And then you can use this local LLM or LLM running potentially in the future running in cancer to say, hey, what is this person's condition? Here are the facts about the history of this person. Please like inference what the condition is. So you can use those type of privacy type questions where you need either one, privacy or also tamper-proofness of the data. And this is not just for like healthcare, it's also for like internal company docs, other things where you really don't want people to come in and like mess with your data. So it's more not about training the data, it's more about fine-tuning existing AI for your specific use case.
Yeah, this is super cool. Like I like the way, and I think this is kind of essential for the future of DAI, like finding those niches where instead of having like a general model, you're going into something like, as you said, healthcare, or maybe even some super technical proprietary that are patented type of, not necessarily developer docs, but technical documentation. So imagine, like, I don't know, aerospace companies that have this large legacy databases of technical documentation on how everything is built. Then if they would like to use a model that supports their engineers, then they would need to train that data. Now, if you're dealing with critical or mission critical type of applications, it's super important to know that the data that the model was trained with is kind of the real data, and it's not something that has been tampered with, and the answers are yeah, go ahead and yeah, just don't just alter the design of whatever. Yeah, I think there are some very interesting points, and maybe Ulan, you can also comment on this if you like, and kind of how this fits in with the Gyrotron. By the way, super cool milestone names.
Yeah, I agree. I think the like very ambitious goal of decentralized AI should be like training or like tuning on chain, right? Like and giving, like making basically AI application more trustworthy. And I agree with you that there are probably some niches that where it makes a lot of sense, right? Like to have this, and I think looking forward, that would be like one of the interesting kind of things to look into, like what are the like applications that would benefit a lot from this decentralization of AI. And as I mentioned, like right now, at least like in my team, we are focusing more on like short-term things we can do like right away, and that's more about like helping with the inference of smaller models. Just before I jump to Gyrotron, I wanted to kind of also mention like the third part in the previous milestone, and that is that in order to kind of benefit from like WASM SIMD, we also need to kind of edit or implement the support for those instructions in the inference engine. And in that demo, we were using like open source tracked inference engine, and we are looking into how to add like SIMD support. Like our initial attempt, like we were first hoping that we would say use like Rust compiler, use like optimization and auto vectorize. That's like not working. I'm not. It seems like the program is just too large. I'm not sure why. If you had like experience with that, with auto vectorization, or like how you plan to improve, like add support for SIMD in your case. So I would be curious about that.
Definitely. We actually are starting with it off the IC with that version of Vectune. So it has SIMD by default. But we're going to be moving it onto the IC as a migration, and we'll connect you with the technical team there and like share all those results.
Awesome. Yeah.
But in the like, there's once I think per week, like a web or a DAI conversation in Discord. I know you join there sometimes as well. But we'd be happy to share like details and how that goes, that process.
For anyone interested, that DAI working group starts in 37 minutes on Discord. So you can join our developer Discord and follow on that after this space. You can join the DAI working group.
I actually don't think they're doing it today. I think it's starting up again next week.
Okay. Sorry. Okay. So today is not happening, but next week it will happen.
Like we would be like, if you have the code, we would be very happy to try out, like to see, also to test the replica implementation. And now moving on to the more ambitious side, like Gyrotron, and that is, I think the goal is like very ambitious, right? Like to run the inference and training of like large models on chain. And this is now like the previous milestone was like very concrete. This is more like in air, I would say. And the biggest question for us right now, and that is like open question, kind of, I think it's almost like research level, is can we get deterministic computation on GPU, right? Like, so in order to support like large models, there is no way around. We need to offload it to GPUs. But since we are running on a blockchain, and the main idea of the blockchain is that we replicate computation on multiple nodes, and then those nodes do the computation, and then they agree on the result. And in order to agree on the result, they need this property called determinism, where if you start with the same input, you arrive at the same output or result, right? And this is open question. So I think that I see this as a main challenge for this milestone to figure out. And this will involve a lot of like exploration, and we probably need help from like AI experts, and also community here.
But why is deterministic computation on GPUs such a big challenge compared to CPUs?
A good question. So like GPUs are very parallel, like they are way more parallel than like CPUs, right? And additionally, they like if floating point is used, there is this challenge where if you have, for example, like in mathematical terms, like it means like there is no associativity between operations. Like, so if you have A plus B plus C, then the order in which you do, like first A plus B and then add C, or first do B plus C and then add A, that order becomes important and could lead to different results, right? So that's like one like open question. Like we didn't look into like deeply into this, like didn't investigate, but my intuition is that this might be like one issue that will arise and we need to solve. Like, and there are of course others due to like parallel execution.
Sorry. One thing that I would say from my viewpoint as well is you could potentially run it off chain and use a different branch of cryptography called zero knowledge proofs. So it would not need to be deterministic at all. You just do the computation somewhere, and you make this cryptographic proof saying, "Hey, they ran this training correctly. Here's a proof that's on chain that gets verified on the IC." So that's one like I've been a proponent of for quite a long time. Like there's some things that we can actually use different parts of cryptography for, so we don't have to work around these like the weeds of floating point numbers to be deterministic. So there might be like mixed models, like in other branches, there's optimistic and there's ZK type things. I think we probably pull some of that work back in to have it, so we have like the best form of a model to run in the IC. But yeah, verification on the IC is extremely quick, by the way, for zero knowledge proofs. It's actually amazing. I think someone like a few weeks ago took this new proving scheme called Jolt. There's like brand new from A16Z and a bunch of famous researchers, and they got it onto the IC like with very, very low cost and very quick developer time. But with other chains, like it takes people months, and you have to do really specific things to get ZK on chain. So I'm always a big proponent of having like zero knowledge proofs verified on the IC.
That's interesting because I see kind of like two directions which are not necessarily too distinct. So one is having these GPU nodes, which I think that IC is kind of uniquely positioned to use this type of architecture specifically for DAI, from the way that consensus happens and from the way the network is actually built. So I think this is one direction, and the other one is kind of having the IC as a ZK coprocessor. If I understand correctly, Wyatt, what you're proposing, right?
Yeah, GPU changes all the time. It's very cost. Like you would have to spend a lot of money to buy those GPUs, and then you have to buy newer ones the moment they came out. You can actually offload that work if you had a ZK coprocessor type process. Just as like a first step, it would be a way to do it. You would there's some overhead of ZK, which is obviously like people are improving every month. We actually have a ZK WASM implementation that's around 100x faster than the last version. Now I think we can it's pretty damn fast, and I think we can actually get some of the stuff on chain in a much more efficient way. So we can actually experiment. So you wouldn't have to buy a bunch of GPUs up front. You can actually just try it out with these zero knowledge proofs to see if it works for you. And then specialized providers of GPUs can actually join the network if they want to do that way, or at least participate via posting the proofs onto the IC.
I'm not, sorry for interrupting.
No, sorry.
I'm not I guess I'm very beginner in zero knowledge proofs, and I know on the high level verification is fast, but actual execution, that's where the overhead is, right? Do you have a feeling of when applied to GPU, what would be the order of magnitude, or
Yeah, there's actually specialized proving schemes just for the use case we're talking about. They use something called GKR that's specifically for training models. And if you use something specialized, it's obviously going to be very quick compared to just a general ZK VM or something like that. So I think if just for the specific problem, you'd fine tune something for it specifically, and it would be quick enough. The cost, if you don't care about the prover cost, it doesn't really matter, right? It's going to be done by some big computer somewhere in the world. That's fine. But if you do, then it's you need to do a little bit of specialization. But with a general purpose like a ZK VM, like a ZK WASM, what you can do is parallelize across 10,000 machines and just solve the problem that way, which makes it quick enough. It really depends on a bunch of different things, the constraints that you have. I think it's super practical now. If it was 2 years ago, I'd be no, that's not going to happen. But now it's pretty practical, and there's also specialized schemes just for that. And I think ZK VM more generally for experimental use cases are pretty good. The last time I saw general overheads for ZK VM in general, it was 500x versus the execution, the native execution, which is okay, is the juice worth the squeeze there? Are we going to wait 500 times what the normal execution is? I really just think it depends on the use case, and GPUs are kind of actually one of those good use cases because they're extremely expensive and hard to get your hands on.
Yes, sounds very, very interesting. And I also, for completeness, wanted to also mention third option that is possible, without determinism, and that is we could kind of go into consensus, right? In a sense that each node performs an execution, and then they together, the goal would be not to say they get exactly the same results, but maybe they can kind of average the result, right? Or do something in that direction. That would involve modifying or getting into the consensus parts of the protocol, but that would be potentially another area to explore. But I guess the first step would be to start kind of use the same patterns that we use for normal execution and see if determinism is possible, and then depending on the answer, branch to different parts. And I guess from community there could be coming zero knowledge based approaches, right? Solutions. That sounds very exciting.
But maybe because now the discussion is kind of back to WASM. So I see that in this Gyrotron milestone, we also have the WASM 64 execution.
Okay, that's the most concrete part actually there. Compared to other parts that are very ambitious, I would say WASM 64, we're already working on that, and the reason why we put it there is that on the replica side, on the internet computer side, we are very confident we can ship it very soon, this part. But we are not less sure on the tool chain side, right? Like on Rust tool chain, because it's not yet. I think last time we checked, it was tier 3 support, like the level 3 support of the compilation target. So we need to figure out when it will become more supported. And also in the WebAssembly standard itself, it's not a standard feature, or it's not considered a standard feature yet. It's one in the last phase of standardization, but it's still not there yet. So that's one of the reasons why we put it just to be on the safe side and the second milestone. It's also related to large models, so we felt kind of fits here.
But I feel that this is important on a much bigger scale, not just for DAI on ICP. So can you maybe comment a bit on how that will impact smart contracts overall, so canisters on ICP, not only related to DAI?
I can say our use case really quickly. We tried to run some LLMs on the IC, and there's something called token, or the response rate is pretty slow. It's restricted by the memory of WASM32. If we had WASM64, we can actually have extremely good memory, which allows for faster responses from AIs that are running on chain.
Yep, and to answer Radu, your question, maybe we were fast saying WASM64, and maybe people don't know what it even means. So by default, the memory that smart contract gets, the main memory, it is 32-bit. It means that all addresses are 32-bit, and with 32-bit addresses, you can access at most 4 gigabytes of memory, right? So that's the main limitation of 32-bit memory. And 64-bit makes the addresses 64-bit, and basically you can assume it's unbounded, basically more than any physical memory that could exist. For initial release, when we release WASM64, we are aiming to be more conservative to start with, and that will probably go with 6 or 8 gigabytes of memory. But in theory, it could grow as large as, for example, stable memory that we provide to canisters, and that could be orders of hundreds of gigabytes, right? So that's the quick introduction to WASM64, and there are indeed use cases outside of AI, and that is with 32-bit memory and smart contracts. There is always a danger that if developers of smart contract didn't think about it ahead of time, that the memory of smart contract grows over time, right? And since smart contracts are programs that in theory should run forever, right? And if they don't monitor it, at some point it could hit 4 gigabytes and then stop. At that point, it kind of the smart contracts becomes broken, because it cannot allocate more memory, but it needs more memory to work. Yes, and that's main kind of that would be, I think, main impact on smart contract development, right? With 64-bit. Even if we have limit, it's kind of a limit that we can increase. For example, in one could expect over time, as we improve, we will increase this limit. With 4 gigabytes is hard limit, and we even core developers of the protocol, we cannot do anything to help smart contracts that hit that limit. And maybe, if I may, I could also mention another feature that's being rolled out. It's not AI related, but it's related to 32-bit WASM, and that is we are introducing the kind of developer-controlled limit. They can self-impose this limit on their canisters to make sure that the canister stops working before it hits 4 gigabytes, right? A way to alert that there's a problem with memory. So it's called WASM memory limit in canister settings, and the developer set it and by the way, we are going to at some point set it by default to 3 gigabytes for all canisters that are smaller than 3 gigabytes, such that even if developer didn't know about this problem, they can get some notification that canister actually went to 3 gigabytes, maybe there is a problem with memory growing.
It's reaching.
Yeah.
I see. So, for example, if I'm a canister developer and I'm just storing, I don't know, a mapping of users and I don't know, their PFP or something like that, then if my user base grows, then at some point we'll hit that hard limit.
Yes.
So with WASM 64, then I don't have to care about this, right?
Right. Like if you are a canister developer and didn't follow best practices, like, so the best practices, so the practice we recommend is to actually use a stable memory, right? Because that's like already 64-bit and it's like larger, and there are like libraries like stable structures that help to work with. So like for storing user data, like images, I think the stable memory is important. But in the context of AI, stable memory is kind of the external memory, right? So like you cannot just take like some inference engine or something and then say like now run on stable memory, because it doesn't know how to call the stable memory. So that's why for AI we need like native memory that is large. Yeah.
So I think that we've discussed and we've said LLM probably 3 times per minute in the last 20 minutes. But what else is out there? Because we just hear about a lot of discussions about LLMs here, LLMs there. What else is out there, and kind of what are the goals that Kinic has in this direction?
Yeah, there's a few different ones that we think are interesting approaches. Liquid neural nets is one that's actually based on like the mind of a worm. There's like 9 neurons interacting with one another, and it's very small and compact and portable. We think it's an interesting approach because of that. It's also pretty performant for things like self-driving cars and things like that, where you need like real-time updates. It also modifies just like a real living brain. If you give it new data, it modifies without having to retrain it, essentially. So we think that's cool, and we potentially see it for like trading bots. Like we have a trading bot on the IC, basically with its own mind. You can interact with other blockchains, and you have like these automated trading bots. That's kind of in our mind, like a B2C type use case. We would love to have people like come to AI.Kinic DAO and like deploy these things that they created by themselves and then run completely on chain for their own personal use cases. Yeah.
So what coins did the AI trading bot ape into?
Exactly. It'd be really funny to see what like the worm brain of liquid neural net would actually decide to do. And I think it'd be cool to have the incentive structure be like, hey, if you trade really poorly, you're gonna run out of like cycles. Like
you're poor. Yeah, that would be a very interesting to punish AI bots when they don't perform. So no more cycle allowance for you.
And that's why it'd be interesting to have those running on the IC too, because there is that like you could potentially train it to actually do that, which would be cool. But yeah, you would need like a super lightweight model, and liquid neural nets are still, I think, super experimental. They're not like widely used. Like the big boom we're seeing in AI right now is really from like LLMs and how they've improved over the last couple of years. And they're like super performant for different types of tasks, but also they have certain problems as well, like hallucinations and things like that. So they're still not perfect, and we do expect things like to become more portable and hopefully have less hallucinations while they become more portable. So once again, like if we can have something running locally, like biometrics for privacy, that's another reason why I like zero knowledge proofs is they actually give you privacy for certain things as well, as long as you run it locally. But yeah, like privacy applications, like I mentioned earlier, if it runs locally, if it's running on the IC, we can have some really cool trading bots, gaming bots as well, which would be pretty cool. I know there's some big projects on the IC that are doing gaming, but you can imagine the gaming robots also being AI based. Yeah.
And how about models like BERT for semantics?
Yeah. Semantic search, that already works really well in the browser and on the IC. BERT models are already pretty lightweight, and they're for semantic search. Basically, they are a pretty decent way to do, like, if you feed it data, it does semantic search pretty well by itself. So if you like practically wanted to have like on-chain search 100% for like something like internal docs or something like that, you actually use it actually directly right now from actually AI.Kinic. We already have an example up there running. It's already pretty practical to run, and it is for specifically like semantic search. So searching for words and relevance among a big block of words. So if you have a bunch of documents or something like that, it's really good at doing those type of use cases.
Awesome. So maybe now let's also take some comments from the audience. So, for example, we have an idea that, or yeah, the topic that, for example, you could audit ETH smart contracts for malicious code, and you could possibly find rug pulls and backdoors with AI on their internet computer. So, what milestone would that be? Would that be available at, for example? So, for example, if somebody wants to do an auditing bot on the IC, would they need to wait for Gyrotron or?
I don't think so. I think let's think about it. If you made a simplified model using something else other than LLM, you could potentially do it right now. If you wanted an LLM, you probably would need to wait for that WASM 64 portion right there. Also, it just matters what you want to train it on. Like if there's a well-known list of 100 things, you could potentially do that like right now with no problem. But if it needs to be like creative and like inference new things, it would probably need to be like a full LLM, is my opinion.
I agree. Like I have similar intuition, and I guess in this case, like we need to be careful. Like I guess like LLM probably cannot prove that like smart contract doesn't have any bugs, right? Like what it can do is detect like common patterns that like correspond to rug pulls and like incorrect behavior, stuff like that. Yeah.
Yeah, but I guess it could detect, for example, a re-entrancy type of problem in an ETH smart contract. I mean, the basic stuff probably that could be detected.
Yeah. Yeah. Mm-hmm.
Yeah. All right. So I think so. We're kind of reaching the end of the time that we have for this DAI space. Maybe we can get kind of like a final overlook from both of you as to kind of how you see the future for Kinic. Also, after seeing this roadmap, which was just released today, what do you see? Yeah, what do you see as the future of Kinic specifically? What are your plans? And
yeah, we are working actually on a V2 of our vector database, Vectune version 2. It's important because it allows you to like update data. Right now, it's pretty stagnant. If you give it data via the UI I mentioned a few times earlier, you can't actually like update or delete things. And Vectune is important because you'll be able to do that now, which is important for like blogs and things like that, where you add in data and you want to remove it. Those are like semantic search type use cases. But really, we want to build out that UI to have push to deploy AI tooling on Web3 for a bunch of different types of use cases, whether it be like gaming bots or bots that you might make that do like bug discovery or something like that. We want to kind of build a marketplace where you can post these things and have other people use them, and you earn tokens or earn Kinic for doing that. And you also spend Kinic for using these tokens and uploading data, things like that. So it's going to be I would say, a very easy way to get into basically push deploy Web3 UI tooling. And the very start of that is this tamper-proof database called Vectune that's already up, running, open sourced, and live today. But 1 year from now, like where will we be? Hopefully there's a few models that are running. If we get some of these other milestones going, we'll actually have those running directly on the IC as well. And since the IC does have like cross-chain with a few different ECDSA and things like that, you can actually use them for some super cool use cases that we're going to be basically a proof of concept do very early on. So hopefully a bunch more things, a bunch of buttons where you can actually push and deploy these things in about a year.
Awesome. I think the community is super excited to get, so we're all excited to get our hands on whatever you're releasing. And yeah, Ulan, maybe just tell us like what's your what is the single milestone that you are personally excited about from the list that we have here? So either from cyclotron or gyrotron or anything else, what is the single element that you're super excited about?
Well, right now we are like kind of releasing the WASM SIMD, so I'm super excited to learn like how much it will improve. So that's like what in the short term. In the long term, of course, solving this problem of how to offload computation to GPUs, right? Like as we discussed, like these three options, and that like is a very big challenge. Yeah. Also, like my takeaway from this discussion is I'm looking forward to learn about this zero knowledge WASM, like once it's available. Also, I'm curious, like I participate in this Tagger forum, and I know the search is like doesn't work well there. So I was curious if it seems like it should be possible to take all the text and like implement maybe a canister that provides a search functionality that I'm curious to try out in my free time. Like,
yeah, if you want to deploy right now, you can actually go to the UI and it can do it like that way, or you can take the open source stuff and do it yourself. I think it's like super possible right now. Like it's kind of what our like main target was when we were building this, is like that type of search. So I think all the tooling should be there for you to try it out. But yeah, in the ZK WASM aspect, what I would say very briefly is there's been a lot of advances in ZK for a bunch of different reasons. But more recently, there's been something called a folding scheme, which is like super memory efficient and super fast. And that's what we kind of based all of our stuff on. We actually did the first open source implementation of something called Supernova, which is really fast, cool proving scheme last year. And it's actually used by like a bunch of different teams in the Web3 space already. It's completely open source, and that's what we built our ZK VM based on. But we've seen like good improvements in terms of performance, and also we have this portability. This is why we chose WASM, because it works in browsers and other places. It's super portable, and we can choose basically the memory efficiency based on the machine. So it's step size in this folding scheme. You can say, hey, you have a bunch of memory, make a big step size, and we can deal with that. Or you're a tiny like phone or something like that, we can make a tiny step size and work on those different machines. So it's a lot about portability, speed, and hopefully ease of use. Yeah, but that should be open source, I would say, by August this year. We're obviously won't be like completely security checked, so like it will have the big tag like use at your own risk until we get that verified. But yeah, we're super excited as well.
Well, looking forward to it. Yeah.
Use at your own risk should be the tag for the entire crypto industry. So yeah, with this in mind, everybody that is still watching us, thank you very much. Don't forget to check out the new roadmap that was just published on internetcomputer.org. Don't forget to check out ai.kinic DAO, and make sure to ask Wyatt on Twitter as many questions as you can, and also Ulan. So with this, thank you very much, everybody, for watching us. And yeah, in the next weeks, we'll have more guests for the decentralized AI live stream. So thank you very much, everybody. Thank you very much, Wyatt. Thank you very much, Ulan. And yeah, let's build the AI.
Thank you.
Thank you.
Thank you so much.